Up until now, we've delved into the intricacies of the volumetric cloud system and multifaceted terrain system of Red Dead Redemption 2. Now we're going to dive into another challenging aspect, the water system.
It may or may not surprise many of you to learn that in video games, water is typically a flat mesh with special shaders applied to it. More often than not, these shaders themselves are merely approximations of real-world phenomena. You see, water has a rather complex relationship with visible light. To aptly render these intricate interactions, a technique known as ray tracing, which many of you have probably heard thrown around in recent years, is required. This method can be used to accurately render not only surface water reflections, but also more complex, mathematically intensive calculations such as refraction. During the development of RDR2, real-time ray tracing was still somewhat nascent, leading Rockstar to opt for more approximations and cost-effective rendering shortcuts you frequently see used in traditional rasterized rendering. Unsurprisingly, Rockstar makes great use of these shortcuts and approximations. One such example are the water caustics in the game.
You can more or less think of caustics as shadows cast by water waves, which they aren't actually shadows, of course, but rather patterns of concentrated light caused by waves and ripples on the water's surface. They only clearly manifest under a direct bright light source, and their angular disposition hinges on the precise location of that light. In Red Dead Redemption 2, the water does project reasonably compelling caustics. However, upon altering the sunlight's position, it's apparent that these caustics are merely static, downward projected animated textures. They're quite simple and notably remain unaffected by shadows, which ordinarily obscure water caustics. However, the simplicity of these caustics doesn't diminish their visual appeal. It's a powerful demonstration to the fact that you don't always need to resort to high-cost rendering techniques to create a significant visual impact. It is worth noting that the game's water isn't only capable of receiving shadows, but also features volumetric shadows below the water's surface, a visually potent feature that is seldom seen in games.
For me, the real standout feature of Red Dead Redemption 2's water system lies in its physics. Rockstar chose to portray water physics using a combination of both 2D and 3D techniques. Real actual water physics has always been somewhat of a pipe dream for real-time rendering. While Nvidia made some headway more than a decade ago with its physics middleware, it's always been limited to a very small scale. That's because to accurately depict water physics, one needs to treat bodies of water as a collection of minute particles, using shader code to fuse these particles together. This is computationally impossible on a large scale in real time. Even today, with convincing marketplace assets like Fluid Flux for Unreal Engine, which showcases remarkable fluid simulation, it's not a particle-based system. It remains a somewhat predefined system requiring a considerable amount of setup work, and it's also not compatible with open-world projects. Basically, Rockstar faced a formidable task in crafting a convincing water system, and they certainly rose to the occasion. Let's delve deeper by first examining the 3D waves. Dynamic 3D waves in video games have been around for quite a while, and it's a mixed bag on what developer opts to use them versus the more performant 2D techniques. For RDR2, Rockstar opted for 3D dynamic waves. To be totally transparent, I'm not completely certain as to how they compute forces for these surface waves. My best guess would involve a dynamic displacement map that leverages fluid simulation calculations. This displacement map could then employ shaders to translate the texture data into 3D surface deformation. Keep in mind, I wasn't a developer on Red Dead Redemption 2. This is purely just speculation. From my perspective, it's not just the 3D waves that make the water in this game remarkable. It's Rockstar's application of flow maps. Flow maps store directional information in a texture, also called a vector field. This can be used to control the UV coordinates for a surface texture and make the texture flow around obstacles or in a swirly pattern, etc. To enhance water's realism, many developers use normal maps to introduce smaller two-dimensional waves to the surface. This is a widely employed technique. However, Rockstar goes the extra mile by using flow maps to animate these normal maps. Flow maps really excel in situations where water needs to flow in a particular direction, such as rivers, as they provide significant control over the water's surface behavior. In this example, we can see the water actively flowing around a rock. Just for fun, I attempted to see if a wagon would disrupt the flow map, and while the wagon does displace the water nicely, it doesn't appear to interfere as water is clearly just flowing right through the geometry. Now here's something that I found utterly remarkable, and that's how the 3D displacement of water also influences the normal map. Observe as I use this horse, don't worry it was humanely dispatched, as a giant mixer. You can see the 3D waves reacting with a swirling motion, and as I lift the horse out of the water, the normal map can be briefly seen conforming to this same swirl effect. I believe it's important to point out that this normal map flow effect could potentially be its own subsystem, entirely separate from the flow maps. Based on the observations and experiments I've done, it appears to be an additional normal map layer that's blended onto the water surface in tandem with the flow maps. One intriguing observation I made was that in more still bodies of water where you can't see the normal map waves or 3D waves as much. The more I disturbed and displaced the water, the more intense the normal map became. I waited for several minutes for the water to eventually regain its calm state. However, eventually just ran out of patience and decided to briefly fly to another location. Upon returning a few seconds later, I found that the water was calm again. The simulation was purged from the system memory, which is a good thing. There's no point in rendering a simulation that's out of sight. Such an operation would only serve as unnecessary overhead.
Before we conclude the video, there was a question that sparked my curiosity when observing a rowboat in the water. How did the Rockstar devs prevent the water mesh from rendering inside the rowboat? Initially, I surmised that it might be some sort of masking system, where rendering is called based on the boat's shape. However, upon examining the inside of the empty mesh of this large boat, I found that the water actively and precisely displaces around the boat's shape. In a sense, this mimics the phenomenon of fluid displacement. Of course, it's an approximation that merely involves reshaping the water mesh around the boat. As you can see, when I position the boat beneath the water's surface, it leaves a hole in the water matching the boat's shape, whereas in reality, water would cascade over the boat. Devoting the resources to code such a feature would be an excessive challenge and essentially futile, given that this scenario doesn't transpire enough in actual gameplay. Well folks, that brings us to the end of today's video. Thanks for joining me on this compact exploration. Don't forget to keep an eye out for our next video, where we'll illuminate the lighting system of Red Dead Redemption 2. Commander out.